Right, question 5. Differential equation. A vehicle P of mass 800 kilos on a straight horizontal road passes a point O with velocity 5 meters per second. So there's my vehicle. Passes a point O with a velocity of 5 meters per second. At a time t seconds later, its velocity is v. So that's t equals 0. And look, I'm smudging. Oh, it's a nightmare being left-handed. So t equals tv. The vehicle is subject to a resistance given by, so it's moving in that direction, but it's having a resistance of 400 plus 4,000 plus 1,600 v newtons. Show that v satisfies the differential equation of that. Okay, so it looks horrible, but what we've got here is an acceleration system. It's going to be decelerating because there's nothing driving it forward, and it's got a resistance. So there's Newton's second law happening. Now Newton's second law in this case is going to be minus 4,000 plus 1,600 v equals mass, which is 800 kilos, times the acceleration. And we know that I can write acceleration as the rate of change of velocity. So that's where the dv dt comes in. Instead of writing a equals, I can write that as minus 4,000 plus 1,600 v equals 800 dv dt. So now it's starting to look a little bit more like that. There's nothing in front of the dv dt there, so I can divide by 800, which means I divide every bit of this by 800, and 4,000 divided by 800 is 5, 1,600 divided by 800 is 2. So lo and behold, if I just write that the other way around, I've got my differential equation. So that's the first bit, so there's 2 marks there. Then for part B, find the time when P is at rest and find an expression for V in terms of T. Well, P is at rest when V equals 0. So the first thing I need to do is to get an expression for V in terms of T. So I have to solve this differential equation, and the only way I know how to do that is by separating the variables. So I need to bring the 5 plus 2v down, and take the dt up. So all I've done is I've taken the dt across. That's a v variable, so it needs to come down the other side. So you get 1 over that equals that. It's up to you what you do here. Now it depends on your confidence with integrating that. You could do a substitution, or you could just recognize that that's going to be ln of 5 plus 2v, and then it's a chain rule, so it'll be times or divided by the differential of what you've got underneath. So 1 over finger will be ln finger times 1 over the differential of that. But if you wanted to do 1 over u and produce a substitution, that would be fine. The question you're going to get tested on isn't going to be an ln one anyway. So I'll take that shortcut, and if you're not happy, you go ahead and perform the substitution. So this side becomes ln of finger times 1 over the differential, which is 2. and that equals minus t, and then remember you have to have a plus c because you've integrated. So that there, if you're happier, I can write that as minus 1 dt rather than just minus dt. Right, I need a constant, information to get rid of the constant, and I know that when t equals 0, v equals 5. So that's going to be 0, so therefore c will be half ln of 5 plus 10, which is 15. So I don't need the modulus there because that's clearly already positive. So my expression here now becomes a half ln 5 plus 2v equals minus t plus a half ln of 15. And what do we want to work out? We want to find the time when p is at rest. So we want to work out t when v is 0. Now you can do that here. We're going to have to keep manipulating this anyway because they want an expression for v in terms of t. So I'm going to do a bit more work. I'm going to take that over. No, I'm not. I'm going to take this over to make it t. No, I'm not. No, I'm not. I'm going to leave that where it is for now, because eventually I want v equals. So that will give me that, and then using the laws of logs, if I'm subtracting, so I can take out the half, when I subtract I can divide, so that becomes a half ln of 5 plus 2v over 15 equals minus t. Now at this point I'm going to answer that question which is, when stationary v equals 0, so therefore minus t equals a half ln 5 over 15, because the v bit is 0. So that's going to be 5 over 15. Right, so on my calculator now I'm going to put in half, see that? Natural log of 5 over 15, or a third if you're faster ahead with your brain. So that's minus 0.55. So minus t is minus 0.55. So t will be 0.55 seconds. So that's B part 1. And then for part 2 we've just got to carry on manipulating this. So part 2, so I've got the half ln 5 plus 2v over 15 equals minus t. So I'm going to take the 2 up, and I'll have ln 5 plus 2v over 15 equals minus 2t. I'm going to get the v equals, so I'm going to undo the ln by taking e's. So 5 plus 2v over 15 on that side equals e to the minus 2t on that side. Take the 15 up, take the 5 over, divide by 2. Take 5 out, I think, to get the answer that I've got. 2v equals 5, 3e to the minus 2t minus 1. So v is 5 over 2, or 2.5, 3e to the minus 2t minus 1. So there you go. That's question 5. So the most important thing there really is to remember how to get your differential equation. Okay, so it's using Newton's second law and then replacing acceleration with rate of change of velocity. With that question, if you can't get that differential equation, you can still get the last 9 marks by just doing your pure maths, which is the separation of variables part. So the mechanics part of that question is only the first bit.